Welcome, everyone, to Mark Voids a Warranty. That's right, today we're going to bust some stuff up. So, Christian, I hope you're watching. I might even bring out the hammer. You never know. But before I get started with that, there's an issue we have to address. We're on a drive for 500 subscribers so that I can take apart this ginormous lens behind me, right? I'm holding out for that. But our subscriber count's starting to stagnate. And what that means, it isn't that you're not doing your job, it's that I'm not doing mine. I'm not telling you to go out there and share this with your friends, with your family, with your friend's family, and with your family's friends. Get this thing out there on LinkedIn, on Facebook, on the gram, everywhere you can, so we can get a few more people in, so I can take this apart. And then my wife stops yelling at me because it does take up quite a bit of space in the office. So, do me that favor. Hit like, hit subscribe, hit share, well, I don't know, hitting's mean. Just press them gingerly, okay? All right, today we are going to take a look at keyboards. But before we do that, I've got a very quick announcement about this. This is a sample board I made for Teach Me PCB. It's a free online web course. It takes about 2 to 3 hours per week. And at the end, you'll have designed your very own board. That's exciting, huh? It won't look like this. Yours will look like yours. This one just looks like mine, but we're using the Raspberry Pi Pico and making a little macro pad. So if you ever wanted to learn how to make a board, go to teachmepcb.com and sign up today. Classes start October 11th. All right. Today, we are looking at keyboards. Here I've got an Apple, a Stream Deck, a very inexpensive membrane-based keyboard, and a somewhat more expensive mechanical key-based keyboard. And we're going to see what makes these things tick. What's inside a keyboard? They're pretty interesting things. Let me get a couple of these out of the way for the time being. Keyboards are pretty interesting things. A lot of people don't know, but there's actually a microcontroller in every keyboard. And that microcontroller has a limited number of input pins because, well, they want to make it as cheap as they possibly can. Whoops. Let's get a Mark view. There we go. They want to make these things... Oh, we're not fully transitioned. There we go. They want to make these things as cheap as they can. But if you look at this thing, like this is probably, 100 keys, 102, 108, I don't really know. I'm going to guess with 102. But how do you do 102 keys with, a limited number of GPIOs? Let's see if we can't find out. This is one of those keyboards that the manufacturer gives you for free. It'll come with your computer, that type of thing. And they're trying to spend as little money as humanly possible to give you that free gift. So these are built a little different than other keyboards. Some keyboards are built for feel, some are built for noise, some are built for gaming, very fast repeat rates, all that sort of thing. This one is designed for cost. By the way, if you have any questions as we go through this, please do ask. I'd be happy to answer them. All we're doing now is just popping the very many screws that are in this thing. And there are quite a few screws. All little thermoplastic, maybe M24s, I'm not really sure, but they're not very big at all, but there are a lot of them. I think I've got them though. Oh, missed one. You guys probably saw that and you were screaming at the screen. Like, Mark, what are you doing? Don't do that. Ah! That's how I think you talk. What are you going to do? Okay, so on the back, kind of interesting. Let's see if we can't get a zoom in here going. Ooh. there's all these little features that I imagine are structural. And they're used to support things. So basically fill space, keep the overall amount of plastic at a minimum, because I'm sure that adds up in mass production, but still provide the structural rigidity that the part needs. That's kind of interesting. By the way, this particular board is not going to survive this. I have no interest in putting it back together. Let's see here. So, other than the glare, you can probably see that we've got these little sheets of plastic with circuits printed right on them. That's kind of interesting, huh? And each one of these, let's get a little zoomed in here and see if you can't see it better. No, I just changed the transition type. Well, that's no fun. Let's get that fixed and go to here. There we go. So each one of these sheets has these little conductive pads on them, and there's a layer of plastic that goes between them. So when you're pressing a key, what you're really doing is pressing two little pieces of that stuff together and creating a connection, right? So it's 3 sheets of this. It feels just like acetate. I don't really know what the material is. In between 2 of the sheets, you've got a layer of plastic with holes in it, and your keyboard is all these little switches that when you press down on them, that little nub in the middle there presses those 2 pieces of plastic together. And that creates the electrical connection that becomes your circuit. And if you can tell here, these things, well, it looks like they're glued together over here. Funny thing, they often do that just with a soldering iron. Just heat it up a little just to keep everything registered in place. So you'll see that on the bottom layer, things mostly go in rows, right? It has to move around a little. And in the other layer, things mostly go in columns. And when you get over here, where all of the traces go together, right, you've got columns across, columns going down, rows going across. And they connect over here to this little cob chip on board. They just put the wafer there with no packaging. Come on out, little guy. Come on. Oh, is the plastic melted over? No. Well, what's going on? Needs a little friendly persuasion, maybe. Let's try this. Get underneath it. There we go. We're working. Said I'm not too worried about putting this cheap El Cheapo back together, but man, this is the cheapest way you can make a board. One-sided PCB, the other side, nothing. You've got some reverse mount LEDs that do the num lock, caps lock, scroll lock. Hiding underneath that hunk of epoxy is the chip. And this thing has probably somewhere about 20 outputs and about 8 inputs. And what it'll do is it'll go to each column. Columns across, no, rows across, columns down. It'll go to each row. No, what would it? No, it will go to each column. And it would energize the column. And then if a key's pressed and you made a circuit, then there'll be a path back to the row. So then it can figure out which key was pressed. So it'll go column to column to column to column to column, energize each column, see if a key's pressed there, and if it is, that'll increase the logic level here. It'll go back and the chip will know what keys pressed. The only issue is, with a keyboard like this, there's no real way to know if you press more than one key at a time. It's possible, and I'd have to show you a drawing of this, and maybe we'll do that in a minute, but it's possible to actually make the keyboard think, if you press multiple keys, that a key that didn't even get pressed got pressed. And that's obviously not good. It gives false user input. So hopefully we'll see in the next design that they took some precautions against that. So anyway, this is a El Cheapo membrane keyboard that it's going to the landfill. Sorry, guys. I know the reduce, reuse, recycle crowd out there, but that particular keyboard is unfortunately not worth the time it takes to put back together. So let's clean up and move on to the next one. Again, if you have any questions as we go through these keyboards, please do ask. I would be more than happy to answer them for you. We'll just get all that stuff out of the way. And next up, we've got a mechanical keyboard. This is a zoom out here for you. This is a Red Dragon that somehow made it into my shop. There we go. So this is a mechanical keyboard. Hiding underneath every one of those is a key that looks like this. And I can zoom in on that for you a little bit. Where's... is that? Oh, that must be my microscope view. There we go. So it's a key that looks like this. And you've got just 2 pin connections. There's room here for an RGB LED if you have those sort of things. And you press it down, and when it reaches a certain point, 2 little metal contacts connect, and it completes a circuit. And this thing is full of them. Since it's full of individual switches, the cost just has to go up. It absolutely has to. But it's got a nice feel, makes a nice clicky sound. Anyhow, this is a Red Dragon. And maybe before we take, well, I have the scope set up in case we want to do a USB feed. I wonder if we should do that before we figure out how to take this apart. Probably we should. All right. So here's what I've got set up for today. Nothing fancy. I have a USB out and a USB in, and I'm just going to hook this thing up. I've already got the scope set up to capture. As soon as we plug stuff in, we'll flip over to that and see what keyboards are doing. But I have to be smarter than the connector. And yes, Christian, it's nice to see you, buddy. I will use the hammer today for you, okay? Just hang on. Anyhow, we're hooked up. So now we're moving over to the oscilloscope. And hopefully what we'll see here, let's go ahead and start running. No, run. There we go. Hopefully what we'll start seeing is some data packets. Let's scale that out a little. Unfortunately, the scope really slows down when you start doing bus captures. Come on. Okay, let's try a single capture. See if we get anything there. Ooh, I'm really making this thing angry. Okay, we're going to have to turn the bus off here. This is going way too slow for my liking. All right, so whether you're doing anything or not, the keyboard is talking with USB. It's getting pulled, it's getting data from the computer and back to the computer. And depending on what key you press, the keyboard is going to change those data packets. And I was hoping to show that to you today, but like I said, it's just going a little too slow. But we can we'll run things and see what happens. But you can see the data sometimes changing over there on the far left. It all depends on what keys are being pressed when. Now, keyboards can, depending on the quality of the keyboard, they can do anything from one key press to multiple key presses, right? You hit Shift Control and something, they should be able to detect that and send it out. But they also, at some point, when you start, hitting this thing with your hand, they start freaking out a little bit. And that's no good. You need a keyboard, if you're going to be doing lots of multi-key combinations, that can handle something called in-key rollover. And in stands for a number. 1, 2, 3, 4, 5, whatever. Depending on how many keys that you're going to need to press at once. So anyways, I was hoping to show you the actual data, but let's not sit around waiting for me to figure that out. Daniel Bogdanoff, if you're watching, feel free to send me a new scope from Keysight, and I can put my Tektronix one in a museum. All right, so now we're back to the teardown. So with the Red Dragon here, it's an aluminum shell. This thing is really tough. Unfortunately, I don't see anything resembling a screw to open up this case. Sometimes they hide those things under the feet. That is not the case here. I peeled those off for nothing. Okay. This one's going to be tricky. I wonder if is it a snap together? Are the screws hiding underneath the keys? I really don't know. Let's see what happens when we take a key off. Anybody out there knows how to put these things together or take them apart? Let me know. Okay, so good news, bad news. I think I see screw holes under here, along with copious amounts of schmutz. Yuck, yuck, yuck. This keyboard is icky. This is not the keyboard from my desk. But here's the good news, bad news thing. I found how to take this thing apart. See, among all that schmutz, we've got screws. So unfortunately, to get this keyboard apart, I wish I would have known this. I could have had this prepped for you. But to get this keyboard apart, we have to depopulate the keycaps. Which means sometime later, I get to repopulate the keycaps. Lucky me. The things I do for you, dear viewer. The things I do for you. It's okay, though. This thing is in dire need of a good cleaning. There's all sorts of keys out there, key switches that you can use. They've got different feels to them, different sounds, different click levels, different forces that you have to apply to get them to go. And if you're really into gaming, that seems to be a thing that gamers really love. Oh, we're not fully transitioned. Sorry about that. Now, I was playing with my keyboard, the one on my computer the other day, and the absolute fastest that I could make a key go by flicking it was about 20 to 30 milliseconds. Most of the key presses that I did were somewhere in the area of 80 to 90 key presses, milliseconds per key press. That means if you're doing board design, you want to make sure that after the thing settles, that you're polling or scanning, would be a better word, polling's something different, that you're scanning often enough that you pick up that key press. And maybe you want to pick up that key press once or twice in case you pass it during bouncing. So if an average key press is, let's call it 50 milliseconds on the high end, I don't know where this keyboard came from, but they are filthy people. Yeah. Come on. They really should have cleaned this. This is yicky. Blah. Christian, I'm sorry you have to see this. If it makes you feel better, I'll put this back on your desk later. Okay, buddy? You don't even have to see that this happened. Most of the keys will even be in the right place. All right. Come on. Some of these things just don't want to pop. Looks like the screws are scattered, I don't want to say randomly, but you would have to know where they are if you wanted to peel off just the keys that you needed to. Oh, this is a little faster. Whoa. I'm getting a little too excited here. We're losing them all over the place. All right, almost done. Thank you for your patience. So, as far as keys go, the Cherry MX is relatively popular. I have to clean this. This is bothering me. Sorry. Sorry, team. It'll be just a second here. The Cherry MX keys are pretty popular. So is, I don't know how to pronounce it. Is it Kale? So if you're into keys or keyboards at all, you've got all sorts of options available to you. More than I knew even existed. All sorts of different force rates. I mean, all sorts of different features. You can get them with LEDs in them, without LEDs. Okay, this is a little better. It's still pretty icky, so sorry, dear viewer. I had no idea we were going in this way. Okay, and remember we have to put this particular one back together so we can put it back on Christian's desk. Christian just left a note that I can leave the MARK keys off. He doesn't need them anyway. I think that's because Christian never calls. He never writes. I mean, the last time he sent me flowers, I don't even know when that was. Christian, I'm a human. I have needs. No, buddy, I miss you and Tracy. I hope you two are well. It's been far too long. All right, so I took out 1, 2, 3 screws. I can't imagine this whole top is held on with 3 screws. Is it held on with switches too? Do I have to pull these switches? Christian, do you know? Do I have to take these switches out to get this top off? I don't know. This is getting interesting. This thing still feels firmly attached, but the only mounting screws are out. So then my next question is, are these keys what's holding it all together? And how hard is it to pull these keys out? I don't know, but I've got tools for this that work better than futzing at it with the screwdriver. Man, those things are really stuck. Are they soldered in? I have so many questions. That isn't going to be strong enough to pry with. Oh. Christian, it might be hammer time. Alex, it might be hammer time. Give me 2 more minutes, and if not, we'll just go ham on this thing, right? We need a cool name for the hammer. You guys start thinking of that. Okay. The keys sit inside a metal top that is attached to a PCB below. So what that tells me is, unfortunately, all of these keys, they gots to go. Man. I had no idea taking apart this keyboard would be so much work. I avoid work whenever possible. Had I known it was going to be this much work, I probably would have taken apart something simpler and gone and gotten ice cream. I'm just going to be perfectly honest with you. Okay, we've got the crowd chanting for hammer. I know. Don't worry. I will hammer something. Uh-oh. That didn't feel good. I don't know what happened, but something, small piece flew off. Get out of there. There we go. If I do hammer this, guys, I can't put it back together. Oh, another screw. Why didn't you tell me about that? You guys are just sitting there trying to get me to destroy my stuff instead of trying to help and pointing out that there's still screws left behind. I tell you, fine friends you are. Well, I don't want to have to be the one to tell you what I'm going to do to this keyboard before I give it back to you, Christian. You do not want to know. Nope, still stuck. Okay, so while we're doing this, in Teach Me PCB, that's the website I talked about at the beginning, we are going to teach you how to make your own keyboard. So if you are at all interested in knowing the inner workings of these things, by all means, join Teach Me PCB. It's a free website. It's built for you. It's free. Did I mention it's free? Man, how did they... I know people replace these keys. Like, they'll take their keyboards apart all day long. They must have special tools for this. Because the snapping sounds that I'm hearing, they don't sound healthy. Does that sound good to you? It doesn't sound good to me. Okay, what can we get in there? I've got my tools at the ready. I need to get underneath these things ever so slightly. All right, so I'm fighting desperately with this stuff. I know it looks easy, Alex. I know it looks easy. It's not. Mostly because I didn't bother reading how to remove keys before I did this, because I had no idea that I would have to remove keys. So let's see if we have any other tools that might make it easier. Can we grab these? No. Can we... I know we can hit it with a hammer, guys. Let's not. Let's see if we can get underneath it with a sharp chisel or something. No, pieces are falling off. I think I was better with my hook. Okay, that one is damaged. We'll put that on a key we don't need. Like F1, which is help. Who needs that? That's like reading a manual. That's not what we do. No, no, no. Okay, so it looks like if you get under the corner with this hook thing, in the right spot, it pops out. And if you get it in with the wrong spot, it messes up the key. So now you know. Just make sure you get it in the right spot. Somebody out there in TV land is watching all of this happen and screaming at the screen because they know how to do this and I don't. All I'm doing right now is damaging keys left and right. These little pins that these keys fit into, they're made by a variety of people. I'm looking at these little sockets. Places like Milmax sell just the sockets for like 50 cents a piece. They are pricey. I tried sourcing some of those yesterday, and I choked on the number. The keys are another 50 cents to $1 a piece. I mean, there's a lot of money that goes into these things if you're trying to make them yourself. So I'd prefer not to break any more of these, but get it from the side. Nope, that one broke. That one's good. The person who gave me this keyboard told me that it wasn't working consistently. Like, whoa, okay, that one's out. Things would, key presses wouldn't register and whatnot. I have to think that might have something to do with the filth and schmutz that's in here. They asked me to look at it to see if it could be fixed. That was a couple of years back. I never got around to it because they didn't want to pay me to do it, so you know how that goes. There we go. I'm hoping, and I don't know if this is true or not, but I'm hoping if I get enough of these out, I can get underneath the back edge. And, okay, come on. There we go. And pry the rest out. But I had no idea that you had to actually remove every single one of these keys. Who does that? Monsters. Monsters do that. All right, so here was my hope. Is that I can sneak underneath the back of this. And see if that extra force will help these things come out. Okay, we'll see. I mean, I don't even know what they did to this keyboard. Did they dump it in, like, soup? Christian? Jacques. All right, Christian, man. Take care. Nice talking to you. We'll see you next time. There has to be an easier way. I just don't know what it is. There we go. It's the nice sound of crunching. Okay. We are at about mark smash time. I think we're at mark smash time. I've wasted enough of your times. But now we can see a little bit more about what's going on the back of these. Is there another screw in here somewhere? Let's look underneath this sticker. Nope, nothing underneath that sticker. Man. Okay. Frustrating, frustrating. Oh no! Where is the Mark Smash hammer? Oh man, I was all ready for it. But we're getting some switches out, so that's good. Man. Again, I know people take these things apart for fun, changing out switches and whatnot. Forget it. There has to be a special tool, and I don't have that special tool because I'm not into this stuff. But that's the only thing that makes sense. I am doing way too much damage to these things, taking them apart the way that I am. We're no longer worried about putting this thing back together. At this point, It's a battle of wills, and I will prevail. It just doesn't know it yet. Really feels like it's locked in. Oh, dang it, another screw. Those things are hard to see. Boy, I tell you, this thing is structurally sound. There we go. Man. Better not be any more screws. There's something weird. I don't know what that is. It's like a registration mark. Okay. Another screw. They have these things hidden underneath the switches. So you really do have to get those switches out to be able to do this. Something that I, of course, failed at. Another screw. That one, well, we got those things out. All right, so the screws are hidden by switches. In case you're doing this later on, you got to look between the screws, which is hard to do because there's schmutz all over it. And also, because I do believe you need a special tool. Okay. What am I missing now? Man, this is work. I tell you, Alex. Let's see. Found an easy way to get the switches out. Silver lining. Yeah, destroy the keyboard. Yeah, that does work. It's just one of those things where a couple minutes on Google would have saved me a lot of pain. I really would have used the hammer at this point, except I seem to have used it somewhere else and not put it back. So sorry about that, guys. I know how much you love the Mark hammer. Jeez. Okay. Feels like there's another screw somewhere underneath schmutz. There it is. So, if you ever take one of these apart again, pop the keycaps, take it outside, hit it with an air hose, blow all the schmutz away so you can actually see what's underneath, and maybe invest in a key puller. I actually broke a sweat doing this. All right, so we got looked up. There is a couple special tools that come with the keyboard. Oh, okay. Well, see, I didn't buy the keyboard, so I didn't get those tools. I just got a keyboard. By the way, amazingly enough, I could fix this. I'm not going to, but I do know how to flatten metal like this. It's not difficult. It wouldn't be perfectly flat ever again. But it would be close enough you wouldn't see, especially with the keycaps on. But look at this. This is disgusting. What did they do to this keyboard? Okay, but we do have some things to look at. Let's see if we can get that PCB out now. My goodness. Talk about more difficult than something needs to be. All right, so I am going to disconnect the connector here, and we're going to actually examine this keyboard. Except that connector looks like it's covered in a conformal coating. Just looks like a JST, maybe a 2.54 millimeter pitch. And maybe a little tighter than that, maybe like a 2.5 millimeter JST connector. We got the keyboard. We got the keyboard. And yes, now, I don't know if you know, but we just made an ergonomic keyboard, right? Or maybe we want to bend it the other way. See, and oh, that feels good right there. Yeah, we don't need that key. These are really the only keys you need. Like the ASDF, maybe we'll put a W back in. I mean, it's still a gaming keyboard. There we go. Yeah, that's not too bad. Oh my goodness gracious. I know I should research, but it's never going to happen. All right, so here's what we got. We're on the top side of the keyboard. We've got some reverse mount RGB LEDs that are peeking through. We've got these incredibly expensive Milmax plugs. We'll take a look at those under a microscope here in a second. On the back side, you can see where the reverse mount LEDs are mounted. They used a Hatch copper fill for some reason. They were either trying to keep the weight down, which I doubt since it's a big aluminum case, or there were some capacitive coupling issues maybe they were dealing with. I really don't know why they did the copper fill here. All right, so we've got an IC, diodes, more diodes, and that's pretty much it. So let's take a look at a couple of these under the microscope. We'll see what there is to see. There we go. Whew! That was work, people. All right, so these connectors looks like there's not much to them. It's just a little bit of a hole. And it tapered. There might be some fingers in there that grab it. The reverse mount RGB LEDs right there. We've got vias in the middle of traces. Let's see where my pointer is here. There we go. So I was just looking at that via right in the middle of the trace. It's kind of an interesting choice. More vias in the middle of the trace. The only thing I don't like about that is the amount of copper that's left around the edges is a little tight for my tastes. They had the room here. I would like to see that increased by, you know, a good 5 mils on either side. So that way if the drill wanders in any direction, you don't have to toss the board. Because this is a big board. All it takes is one mistake to destroy it. And there's schmutz all over this board. It looks like flux, but with as filthy as this board was, who knows if it actually is. It could have been left behind by the previous user. Here's something that looks like a spacer. I was wondering if that was something I ripped off. I don't think so. I think we need to take a minute to talk about how this board was designed, and then we will talk about how boards work. I'm telling you, if this much stuff comes out of your board, you should probably clean your board a little more often. That's all I'm saying. I want to say I'm not judging the person that gave this to me, but I'm judging them a little bit right now. I really am. All I'm looking for now is my clipboard, which is sitting underneath the other keyboard that I had to take apart today. And we'll talk for a minute. All right. If you're unfamiliar with PCB schematics, we often use symbols to denote things. For example, that's a switch. That's another switch. Another switch. Another switch. You can draw them in lots of different ways, but I just want to give you a general idea of what a matrix keyboard would look like. And then one more row. All right. So each one of these columns would get connected. And each one of the rows would get connected. Oh, I connected the wrong thing there. Oh well. I'm going to have to draw this again. I'll do a better job on the next one, I promise. I just want to give you a basic idea here. So these would all be inputs. And these would all be outputs. So whenever the keyboard scans, it would go through and it would energize this first one. And if a key was pressed, then current would go through that key and it would come out the row on the other side. If a second key was pressed, like this one was pressed down, then it would notice it when it energized the second column, and the third column, and the fourth column, and whatever. So you can actually recognize many multiple key presses with this system. Even if you pressed this one down, no problem, current would go through this one. So this system works just fine for most keyboards. This is just a matrix scanning thing. There's not much to it, right? But what gets interesting is what happens when 3 keys are pressed at once in different rows and columns. This one I'm going to be a little more careful about drawing. So I'm going to draw these 2 depressed, and I'm going to draw the next 2 open and then pressed. And then we are going to connect them. This will be column 1. Column 2. Row 1, row 2. All right. We'll put some tie points so it's abundantly clear what's connected to what. All right. So here's our setup. Switch 1 is down. Switch 2 is down. Switch 3 is up. Switch 4 is down. Okay, they're connected. What happens when when column 1 is energized? Well, when column 1 is energized and switch 1 is pressed, current can go through that switch. And switch 2 is pressed too. So what happens is current back feeds through there, comes down. Oh, look, switch 4 is pressed too. So now row 1 and row 2 are lit up. Here's the issue. If column 1 is energized and row 1 is energized, then the system knows switch 1 has been pressed. But it also thinks switch 3 is pressed. but it's not. So it's a false key press. This is the way that the first keyboard that I showed you works. It's just straight connections. And if you press the wrong combinations of keys, it doesn't really know what happened. Here I've got 3 keys pressed, but the system would think that switch 1 and switch 3 are pressed, not switch 1, switch 2, and switch 4. Well, what do you do about that? Well, the trick is to put a diode on every key so that the current can't go backwards. So out of every key, every switch, you've got a diode on it so that it can't backfeed into the system. It can't backfeed into the matrix. So all of this stuff goes away. Probably a whiteboard would have been better, but I just kind of wing these things. Anyhow, that is what this keyboard has. That's what these diode matrices are for. And you can't really, I mean, you can make them out. See these little things here? There's one on every key to prevent the system from backfeeding on itself. Kind of interesting. All right, now let's see what it takes to get some of this stuff off. What do you say? What do you say? Hi, Chester. So, one of the new toys that I have is this little guy. This is a, let's go to another screen here. A Hakko soldering iron. And how does that tip come off? There we go. Just slides in and out that way. Whoops. So we're going to turn this on, hopefully. Do we have power? Okay. And then I'm going to give this a moment to heat up, and we're going to see if we aren't able to salvage 1 or 2 of these components. While I'm giving this a moment to heat up, if you do have any questions, again, please feel free to ask. The only thing that might stop me is this lousy conformal coating. That shininess on there, they covered this board in something, probably to prevent ickiness from disturbing it. Which, by the way, I totally applaud, but I don't know if it worked. This was a disgusting board. I feel like I should have worn gloves. The things I do for my employer, I tell you. Okay, let's see if we can heat this up and do anything with it. Doesn't look to me like it's melted yet. No? Hi, Chester. There we go. Okay, are those loose? Nope. Excuse me for one moment. Mr. Chester needs up. Come here, Bobby. Oh, there you go. He always gets ignored during live streams, and that makes Chester sad. So let's just start up here in the corner and heat one of these puppies up. Heat her up, suck the solder, give it a whack. Yep, so these are recoverable. These are the little guys that sell right now on DigiKey for 50 cents a piece. So once this stream is over, I think I'm going to take a minute and recover a few of these in case I want to use them in some future designs. Wow, that was an hour. That was difficult. more difficult than it needed to be because it was filthy dirty and I didn't want to touch the ickiness to see the screws. Anyhow, that was a different Mark Voids of Warranty. I tell you, I had no idea that it was going to go this route. So much pain, so much destruction, so much fun. All right, just to remind you, sign up for Teach Me PCB. We're going to learn how to make your own keyboard so you can take keys and drop them right in to your next design. You can maybe make a flight simulator with a bunch of switches on it. You'll learn how to do that. So sign up for that, teachmepcb.com. Make sure that you share this with your friends and family, your friends' family and your family's friends, so that we can get up to 500 subscribers so I can take apart this bad boy, right? And if you, as always, if you ever have questions or you have needs, please visit aapcb.com and we'll see what we can do to help you out with them. All right, that was an hour. Thank you for your participation in the video today. I really had fun. I hope you did too. Take care. Bye.